So I realized that I'm the last one that stands between you and the Friday party. So I'll try to make it so that it is worth being here. Couple of things. So yeah, I was introduced. I've been in this field since IRIX exploits. I don't know, does anyone here remember IRIX? One person. Okay, so two of us, right? So it was like before some of you were born. And this is, I'm saying this not because I want to say how old and cool I am. I'm not. It's just because for the research that I was conducting here, the many things that I saw, they look so similar to the stuff that I saw in 90s. So the situation is not really improving. Yeah, besides that, I was involved in both InfoSec and IT operations many times, and it's helped me a lot. And I recommend many people to switch sides from time to time because it gives a different perspective. And when you're on the InfoSec side, you're always like, why the hell those IT guys are not moving or whatever. And then when you switch it over there, you usually think like, those security people, they have no clue at all. And yeah, I've been on both sides of that, and I really like it. So nowadays, I mostly do PowerPoint, to be honest. But once, I had some free time, and I got bored, I guess. So besides PowerPoint, I decided to run Nmap. And this is how this story started. So there was a net. And it was a very traditional office network, like nothing fancy, right? Reasonably well maintained. And this is a simplified scheme of it. So there was a couple of VLANs there. There was users VLAN, there was management VLAN for security devices, and there was a separate security devices VLAN. And if you ever had to maintain all those access control devices, you know that they're usually hugely outdated. And software for the management stations is also like, I don't know, I think in that case it was Windows 2003, and vendor insisted that no updates should be installed because reasons. So I was scanning that network, and at some point I realized that although it was expected that a configuration would only, on the firewall, would only allow communication from the management VLAN to those security devices and access control VLAN, that due to a misconfiguration on the firewall, where the admins, I guess, wanted to let users access many things on the internet, inadvertently they also made it available, the security devices VLAN. So a mistake, but I think it's a pretty common one. So if you look on a typical enterprise firewall, you probably will see something like that. So when I was looking at that particular network, I found something interesting. The password was default, of course, like admin or something. I don't remember what exactly what that. And I found that, right? Like a typical network settings thing. But then besides network configuration for that, and I knew that this seemed to be somehow related to access control, but I didn't know initially what exactly that was. But I found the firmware update page. So I thought, okay, firmware. So I went to a vendor site, and yeah, a side note, we are not disclosing the vendor at the moment because I'm still trying to get them to confirm something that I will reveal later on, and issue a fix. Hopefully, sometimes this century they will reply, and hopefully in this millennia they will release a fix, and then we will post a blog or something. So I found a firmware, right? And I went to vendor side, download firmware, run build walk. If you ever had to deal with the firmware, you know how to do that. It's pretty easy stuff. So download firmware, run build walk, found what do you expect to find there, the ROM-FS file system over here, Linux kernel somewhere. extracted file system, mounted it, and look at the files. Out of all files that I found there was a passwd file. And yeah, I got curious. Why would you need a passwd file there? Right, so why passwd? And yeah, of course, because this is a traditional Unix hashing, it was not hard at all to get to the. Although the password is, I would say, reasonably secure. It's not a vocabulary password. It's not a dictionary one. But yeah, nevertheless, it was traditional Unix hashing, so it didn't take long to get a password. So why would you need a password? I thought, okay, there should be a reason for that, and that password was different from the one default that I had on the web interface. So I started looking around. There were a few things in the TC folder, and the interesting one was that dropbear. Who knows what dropbear is? Yeah, right. Dropbear is an embedded SSH daemon. The SSH daemon is typically used in embedded systems. So lower size, less features, reasonably well suited for smaller devices and less powerful devices. So, okay, dropbear. Dropbear is interesting. But when I was scanning this device, I didn't find a way, and I didn't find SSHD actually listening anywhere. So there was no SSH port open. So I thought, okay, there should be a reason why dropbear files are there, the dropbear binary is there, but it's not listening. So there should be a way to start it. So I look in obvious places. Init tab, nothing found. etclc, also nothing of particular interest, except for I realized that the device is initially configured with a static IP address, and only later on it is reconfigured with the one that you have in your configuration settings. And that gives you a window of opportunity to attack the device. In a dconf, and also again, nothing of interest. So I thought, okay, it should be like something less trivial. So I started looking at the binaries themselves. There was a standard one, like the typical BusyBox, what you would expect to find in an embedded system. And then there were a few that were not something that I would expect. And they seem to be related to the main function of the device, which is scanning fingerprints and checking cards, like those access cards that you use. So, and you see dropbear there. So at this point, I was reasonably convinced that there is a way to start SSH daemon there. I just didn't know how. So, and also the interesting thing was that, as you can see, those binaries, those executables are not ELF, that what you would expect on a typical Linux system. That is what is called bflit. And those are coming from, I think now abandoned UC Linux project. So bflit is a pretty simple format, a pretty simple binary format. So what you've got there, unlike ELF, there is no header almost at all. There is no metadata, nothing. Like all you've got is a certain, where is it? Yeah, at the address 40 hex, you just have your raw data segment and nothing else. It could be gzipped, or it could be just raw. And I started looking at binaries, but I don't go into details how I look in multiple binaries. But at some point, I looked at the HTTPD, the one that was serving web pages to me. So we realized at that point that this is actually a Boa web server. And again, this is an open source web server. Interestingly, it was last updated in February 2005, which is like 14 years from now. And at that time, it seems to be a top notch and was used in UC Linux project. And again, interesting, it runs like under very limited memory conditions. So the way how it works is different from like Apache or Nginx. The way how it works is that you need to register handlers for the URLs that you want to serve. Okay, and yeah, Biflit is also interesting because IDA initially didn't have support for it, but thankfully there are tons of plugins for it. So we did manage to figure it out. So, and out of all callbacks, out of all functions that were registered, there was one that was particularly interesting for me. This one below. For the URL that ends with /isshd.htm, it would run the function that we call bring up SSHD. And that did this. Here you go. Our wonderful drop by a binary. And then it's also out some text. Interestingly, the same text you can find on the file system, which was the way how I initially discovered it. And then if you hit on the real running device, if you hit the secret URL that was not documented, then you will see that. And then, if you scan the IP address again, you will see this. On port 8009, there is a dropbearer server listening. Yeah, and then that's it. Now, who thinks this is a backdoor? Who thinks this is not a backdoor? Who thinks you can exploit it? Who thinks this is a vulnerability? Really? Seriously? No? Okay. It is a feature. Okay. Well, you're probably an embedded dev, right? Whether it is vulnerability or not, I mean, this is all terminology discussion. But I think that if you have a static password, yeah, okay. So if you have a static password and a password that was not documented and the functionality that was not documented, maybe you can qualify this as engineering access. But I think many of us know the story about some Chinese telecom producer that was recently slammed for much less level of engineering access in their devices. So, I don't know. But that's not all. So I promised you like virtual to physical and also physical to virtual. So if you look at a typical device, they all are the same. Like if you go to your office and look at those, you usually will see that like the interesting property of those readers is that they are mounted outside of your security perimeter, right? So they're outside of your door. And also, they usually have a screw. Like I checked about, I think, 10. And all of them, they had a screw down there, like somewhere on the side or on the button on them. And if you, so you just, with one screwdriver, you can open them. And once you open them, you'll see that. So we have a couple of things here. So this one in the middle is obviously a Ethernet interface, right? But this is a modern device. But the thing with those systems, that their lifetime is also like years or maybe like 10, 15 years. So they have to be compatible, backward compatible to something that was invented back in the IRIX exploits time. So that particular device had two more interfaces. One is Vagrant, and another one was Zeroport. So WireGround is interesting. WireGround is 3 wires. One is ground. One is used to send zeros, and another one is used to send ones. And that's it. No flow control, nothing. No authentication, no whatever. So, and then there's another interesting feature of those devices is that they're usually designed so that they still operate if you have lights out. And then some of them are file open, some of them file close. Some of them try to work if your management server is not reachable for whatever reason. And I think that's a good idea. Like, I don't want to be locked out in a room with a server. So the way how they do that is that they have a local database. I'll go into more details here. I think so. They have a local database of all cards. And in case of this specific device, they also had a database of all fingerprints on it that were presented as a specific type of a card, of access card. So there are those wonderful guys outside there, the RFID research group, that and they didn't pay me for this advertisement, but they sell RFID readers. And if you get into such device and you have a full database of cards down there, all you need to do is just to program your card with the IDs that you have. So which means that you attack this device over the internet, you grab the IDs, you program your card, you walk to the door, and you open it. And that's how you get in. And more interesting, if you cannot do that for some reason, you just take a screwdriver. It's very low tech. You open the device, you connect the WireGround interface, and then you just send the command to the controller that, okay, I have the right card. Interestingly, you don't even need to know the ID of the card, because the controller just trusts the reader that it has the right card, and that's it. And then there are a couple more things, because I said that this thing is high-tech, like it's a modern equivalent of it. So it is not only communicates over those legacy interfaces, but it also communicates over the modern, secure, and encrypted protocols. So here's an example. That's a configuration file from the from one such device that is set up to communicate with the controller over the internet, or over the Ethernet, over the IP. So as you can see here, the communication is encrypted with a triple DES, which could be sufficiently secure by nowadays standards, except for that we know that triple DES has just 3 consecutive applications of the legacy DES encryption protocol with different keys. So in this case, as you can see, the second and the third key, they were empty, which effectively reduced the security of the communication to a single DES, which is 56-bit key, and which could be trivially broken nowadays on your laptop. But I bet the vendor claims that like the communication is encrypted. Thank you very much. So what can we do here? Like what is the take from here? So you can go from virtual to physical. So like while you're on the internet, you somehow have remote access to this device, you can break in. Then you can dump your keys. You can program your keys, and then you can like just walk in through the door. And interestingly, because you're cloning a real key, so there would be probably little suspicion. So now from the monitoring perspective, nothing special is happening here. Like just another employee is walking into the office or in your data center or anywhere. Now, the other way around would be that you unscrew this device, you connect to Ethernet port, or you connect to Vagrant port, and you send a command to controller. Again, the keys are static, so same as passwords. So they are the same, I bet, like 99.9 devices worldwide will have the same key. And then I thought, okay, maybe I got unlucky with this research. And, you know, sometimes you just had one legacy device or one legacy model, and then the rest is fine. So we went ahead and downloaded all firmware files that this vendor, for all different devices that this vendor produced. So what we found was this. There's a how many? 1, 2, 3, 4, 5 different firmwares from different devices from the same vendor that all share the same SSH host key. So not only all devices of the same model worldwide share the same SSH key, but also multiple devices from different models share the same SSH key. And the private key is there in the firmware that you can download, which means that if you represent an organization with an ability to control traffic over the internet or over some networks that is supposedly to be secure, or maybe they're not, you can trivially make man-in-the-middle attack here, because you know private keys. Again, they're static and they're the same everywhere. And you guess what? There's SSL keys for HTTPS. So the vendor does use HTTPS on their management interface. But frankly speaking, it doesn't help. Because again, the keys are not only the same, like not only they are on the firmware and they are static, they're also the same for all devices, and they're the same for all multiple models of the same device, of the different devices. And again, so that means that HTTPS man-in-the-middle is trivial. Yeah, even though you can imagine that people like would click accept anyway in their browser, so maybe this is less relevant than SSH, but nevertheless you can do man-in-the-middle and no one would suspect anything. And then of course, this is actually an improvement here. So there are two kinds of static passwords and different models, but they're all static. Yeah. And then it was shown. So now I want to do a quiz. Tell me, how many hits did I find? Who thinks I found less than 100? No. Who thinks that I found less than 10? Okay. Who thinks that I found less than 200? But more than 100? One person. more than 100, but less than, between 100 and 200 devices untrodden. The devices of this time. So what I did, okay, yeah, some explanation here. So I look at HTTPD, and I look at the signatures that HTTPD produces. So you can reliably identify those devices on the network. They have some unique properties, and they are distinctive enough that you can use Shodan to search for them. So I did a search. So what do you think? How many devices did I find on the internet? Less than 100. Between 1 and 200. Okay, between 2 and 500. Okay, between 2 and 500. Okay, between 500 and 1,000. You're pessimistic. Between 1,000 and 2,000. Okay. Between 2,000 and 5,000. Between 2,000 and 5,000. 10,000. No. Okay. So I think it's not that bad, right? I think that wouldn't be the largest botnet in the world, but I think it would be pretty decent. And also, it would be very hard to actually remove the attacker from this device, because I don't know about you, but I'm not aware of any malware protection or any other form of protection for the fingerprint readers. So it is not hard at all to set up a botnet that would be running on those devices. But that's not it. That's not all. Because what I found was that when you update the firmware, there is no validation at all. I mean, there is a validation for the consistency of the firmware, apparently, but there are no cryptographic signatures whatsoever. Which means that, yeah, and firmware, by the way, was like I downloaded it over HTTP, not HTTPS. But I think comparing to everything else is like just a minor thing. But interestingly, that means that if you get a hold of your firmware, you actually can Trojan your firmware and then run an update, and the device would be safely updated, and then you will get it like something that you probably cannot do anything with. Because consider this, I could make a firmware that would change the password, change default passwords, and probably even disable, if you look at original stuff, what they do here. Just give me a moment. Here they are. So upon startup, after mounting the file systems and blah, 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 and bringing up the network, they run a root shell on the console on this serial port that I mentioned. So actually, you don't need all that. Again, if you have a screwdriver and you can connect to a serial port, you just get in. But if I'm an attacker and I want to build a firmware that would not do that, that would disable SSH password or change SSH password, and it would change your admin password for this HTTPS interface, that probably would be not easy to get in. So the device would be there just running, you probably would never discover. It will be just keep functioning. But even if you discover that it is broken into, you cannot get in. So I think this is very nice add-on to the whole situation. So you can do from physical to virtual. You can go back from virtual to physical. You can do both, and I think this is pretty nice. So with that said, what do you think? What is missing from the whole presentation here? What did I miss? Solution. That will be a good one. So we are working with the vendor that responded to us, but they didn't yet issue the patch, and they didn't even confirm yet that this whole thing exists. This particular vendor has a history. I mean, they are not different from any other vendors in this field, so they are not particularly bad. They are from the security standpoint, they are the usual ones. So they have a history of vulnerabilities in their products. They seem to fix them somehow, but I don't know how many of you did ever update the firmware of your access control devices. So in the situation that I encountered, that was done by an external vendor, external to the company. And this external vendor took the full responsibility for this access control system. And as I mentioned, for example, they insisted on a particular operating system on a management station. They insisted on that they manage it and as they wanted. And the security team was not able to do much, at least back then. I don't know what is the situation right now. I was not able to do much about this whole setup. Do you think I missed anything else? No? All good? Okay, when Steve Jobs said one more thing. So there's an LCE. This whole thing. There's so when you look at those all things, and the reason part of that is that when I looked at the build times of those binaries, that was, I think, 2013 or 2014, something like that, or 2012. It was the last working day before the Christmas. And the build time was 5 p.m. something. So the guy who built that, this whole thing, he really wanted to go on vacation, right? Very much. And for those of you who work in software engineering, we all know, right, that, okay, the pressure is high, the deadlines are always in front of us, so we really want to do that and move on. So he did that and moved on. And unfortunately, he made a mistake. It's a pretty, well, okay, I don't want to say it is trivial. I don't want to disregard the efforts that went into that. But there was a buffer overflow in the metadata, specifically in the HTTP host header, that went to, in the end of the day, it went to ability to override the memory and led to the heap corruption, which in turn, in a classic way, went to remote code execution. Again, unfortunately, I'm not going into more details right now because we expect to get back from vendor and we expect them to issue fixes for that. And we also hope that people will update the firmware on their machines, on their security devices. And now, that's it. And many thanks to the people who helped me. And I'm happy to answer your questions.
Great. Thank you so much, Kevin. So, yes, applause for Kevin, please.
Thank you.
Now we'll do questions from the floor as well as from Slido, and same thing applies. Best question or most upvoted question gets a prize, and Kevin also gets to choose his favorite question, and he's got lots of nice goodies from
I have some goodies indeed
to give. So, any questions from the floor, please? Yes, sir.
Is this your daily CISO work?
No, my daily CSO work is PowerPoint, budgeting, PowerPoint, Excel, email, budgeting, Excel, meetings, and then sometimes Nmap.
This for security to go home.
Yeah, right. So no, that's not the usual thing, but I feel privileged that sometimes I get some spare time to play with interesting things.
Any more questions from the audience? Yes.
Hi, just now you mentioned almost all model has the same public key, right? Just now. So what's your advice to protect against it by setting?
Well, if I were designing such things, what I would do I would generate the keys every time the device booted, and I would hope that that is better, because in a situation when every key is different, like the problem with embedded devices is that you don't have much space to store your stuff. The keys are not big, and like you usually can find a couple of kilobytes to store a key, but the other problem is that sometimes from the cost perspective, those devices they only have ROM and RAM, and they do not have NVRAM at all, right? So when you reboot the device, it just goes back to factory settings. And what I would do in this situation, I would generate the key every time, and then I probably would send CSR to the management server. And then the management server would be returning a full certificate, and then I would keep the certificate in RAM, and then it would be like, first on one side it would be trusted, on the other hand it would not be easily meetable. But also, if you speak about SSH, then I probably wouldn't want to have it at all. So it is okay. I'm not an embedded developer here, and I don't have a lot of experience, and I cannot judge. But I do believe that a serial port would be enough for debugging, and you don't really need to have an SSHD running on your production system. And on top of that, you should, if you do, please document that.
Okay, any more questions from the audience? If not, can I ask one?
Yeah, sure.
Okay. I wanted to ask you actually, how many different types of fingerprint scanners did you test?
So we looked at, I think about 12 or 15 firmwares. So we find 5 that were closely similar. And then we found another family that used a more modern version of Linux. And the stuff that they did there was done a little bit better from the security standpoint. But also those seem to be the devices that had more CPU and RAM. And probably the developers had to make less trade-offs when they're doing that stuff. And so overall, as I said, we were looking about like 12 to 15 devices, and 5 of them had those properties.
Okay. I've looked at this for a bit, and I've come across 2 readers where the way they perpetrate the fraud is they use residual fingerprint. Did you come across that? And also another way was an overriding hard-coded password.
I think this is okay. I didn't explore this possibility here, but I definitely think it would be doable. And again, like those devices, this particular device was designed to work offline. So it kept all the state locally in RAM, which means that as soon as you get hold of it, you can do whatever you want.
Okay. All right. All right. Yes. Please, yes.
Go ahead.
We still have time. Go.
Hi. You mentioned a lot of proprietary protocols, proprietary technology. Do you think open source would help in this case?
Good question.
Oh, it's a good question. Data shows that open source does not mean that it is secure. So this device, most of it was built on open source stuff. So open source web server built together with OpenSSL, and you guess what? The OpenSSL was from like 2009 or something, and you had there what you expect to get there, everything of it, all of it. So no, I don't think it is going to be more secure because of using in this particular case of using the open source software. I think what would help would be using public standards for those communications between those devices and the control server, or between the logs and the readers, because there is also another problem. The way how those systems work is that you have a reader. So the reader talks to controller. The controller talks to the log, to the real log that opens your door, right? So the authentication scheme, as I said, like in this case, it was very rudimentary or non-existent at all, almost. So it talks to controller, and then the controller signals to the door to open it. So I think that were this protocol open, it could be better implemented than what we have witnessed here. And so that would help. Whether the implementation will be open source or closed source one, I don't think it is significant.
Okay, I think now would be a good time to go to the questions on Slido. We've given it enough time to warm up. So,
Sure.
We have one question on the top with the highest number of votes so far. Given the immutable nature of biometric data, what are the best custody standards you've come across to stop attackers from immediately being able to use this data, make use of this data?
Okay. I think the best way to protect biometric data is not to store it at all. And I think that the biometric authentication is actually worse than anything else, particularly because you cannot change your fingerprints. So if your fingerprint got leaked, like, you're done for the rest of your life. This is not something you can mitigate, like, not at all. And I don't think that any technology, any standard, any regulation, anything will protect us from the biometric data leakage. Last year, we in Singapore witnessed the leakage of some sensitive data multiple times. And there were regulations in place. There were protocols in place for all that, but that didn't prevent this data to be from being leaked. So I don't think that we, as a society, at this point, are capable enough of developing anything that could adequately protect biometric data. So the best thing is not to keep it, not to use it at all.
And you have got a vote of approval from the questioner because he says, excellent answer. You just edited the question.
Thank you.
So who is R? You want to identify yourself? You can get a nice
Yeah, I think
prize.
it's a very good question. I have a
Is that really you? Okay.
Yeah, come over.
Yeah. Okay, how about the next question while we're waiting for this young man to come over? Any thoughts on the recent breach of Suprema's BioStar 2 security platform? Ooh.
To be honest, I have no idea what they're talking about. So I haven't heard the news. Sorry, but there are so many breaches like happening every day, every week, that I think it is easy to miss one. So sorry about that. I don't know what is this about.
Shall we move on to the next one?
Yeah, I
is
guess
it
so.
possible? Sorry?
Yeah, sure.
Yeah, it's basically the web platform where they authenticate you for your biometrics, and everything failed because they kill the web platform. And this affecting 83 countries in the world, 1.61 million people.
Okay. So, well, I think like in this case, the biometric data is just another type of data, and there's this particular breach then has nothing in particular to do with biometrics, right? This is just another breach of a web platform that happened to store sensitive data. And as I said, I think that the current state of software development and current state of security is just not mature enough to store this kind of data that you like have to carry with you for the rest of your life.
All right, we have a new question that's come up to the top. Is there a possibility to fool biometric scanners if you're able to open them up?
Yeah. Yeah. So couple things. So if you open them up, as I said, there is a database in there. And for this particular vendor, the way how it works is that they interact with the reader itself, and then from the reader they get a large number, a vector, a binary vector that represent the fingerprint. And they in this situation they were storing it as a in the same way as they would store the card ID. And then they would just compare, like upon the next scan, they would compare with with existing table. So I think there's a full bunch of attacks here, from SQL injection through the biometric reader, and I think that would be pretty cool. And then when you can do whatever you want and open it up, to the ability to actually clone the fingerprint image. And this is also available everywhere almost. So you can definitely fool it this way. And probably if you think about it a little bit more, there will be other ways to do that. But again, for this particular device and for about 10 others that I reviewed over the last year, you don't need all that. You need a screwdriver. That's it.
So who is T? You want to identify yourself? I think you get a prize for most upvoted question. You want to come up and... I think you haven't taken your prize yet. Later, okay.
Okay. Come on.
Great, wonderful, well done.
Thank you very much.
Okay, next, we still have about 8 minutes, so we can answer a few more.
Yeah, sure.
Do you think with ARM Trust Zone or Intel SGX, it'll be safe to store biometrics data?
No, I don't think so. So, first of all, there's no magic in there. I said today to someone that I discussed this before the talk, that there is no hardware. There is no such thing as hardware. There are just Linux boxes with a very old Linux kernels. So everything around here that would be just Linux. Okay, in case of Intel SGX, I think this would be Minix instead of Linux, if I'm not mistaken. But this is inherently software. So you can communicate with the software. You can try to fuzz it. You can try to find bugs it. You can try to download the firmware, and then you can try to reverse engineer it and find bugs this way. So it is always going to be software, and it will always going to have bugs in it, and you're just back to square one with all that. So no, I do not believe that, again, as a software engineering industry at that moment right now, like in 2019, we are capable of producing the software that is secure enough to hold this kind of data. So we just shouldn't do that.
Okay. We've gone through that one. The next one down. Given that the end user application of biometrics is heavily IoT based, so sensors, ID readers, so on, would you say those IoT devices are the best attack vector to target this data?
That's an interesting question. I was thinking about attacking those devices a lot in terms of the ultimate persistence and on the network. Because if you get hold of this device, then you are on the network, and it's very hard to irradiate you from this network. Because again, like there are no endpoint security, anything like that, and those devices are usually not considered a security threat at all. So I think from that perspective, okay, I'm answering a little bit different questions, but anyway, I think this is a valid point to make. So from that perspective, I think those devices are a very valid target. If we think about the persistent attackers, I think it is very reasonable way of getting initial foothold on the network, but also to maintain the persistence on the network. Now, if you think, does it make sense to attack those devices to collect biometric data? I think it's not, but it's not because it's hard to do, but it's mostly because you won't get a lot, and second, it might be not useful. Consider the fact that, again, for this particular device that I researched, you don't get a picture of the fingerprint, right? You get a binary vector that didn't look like, at least to me, it didn't look like a picture. So I didn't manage to figure out like back to the image of the fingerprint. So I don't think it is. Maybe I'm wrong, but I don't think it is. So even if you break into this device, what you will get some kind of hash or whatever that represents the fingerprint. You don't have the fingerprint yourself. So it probably would be less useful. And then the second point is, you just mentioned this biometric website break-in where you get millions of fingerprints or biometric, some kind of biometric data. If you break into such device, you will get, I don't know, a few hundred, maybe. So unless you're targeting a specific organization or a specific person, I don't think it makes sense. And by all means, please don't do that. Anyway, yeah.
So maybe we can take the last question on clone and Slido, and then we can go back to the audience.
Sure. Is it possible to clone one master control card to access all card scanners? And I like the next one as well.
Okay, you can take that as well.
So from what I learned, and like over the last year, and also from what I learned today from the RFID guys, it seems to be possible. It is also system dependent. Seems to be system dependent. So I think that at least for some systems, yes, it is doable. And maybe there are others out there that I haven't seen yet that make it hard or impossible.
So
Yeah, and then a question on the perimeter defense. I think perimeter was obsolete long before that. Like 15 years ago. So yeah, not because of this. So it is, but not because of that. And physical security, yeah, I think we as a like this locks industry, I think they actually progress a lot. So I think it is possible to make a device that would be hard to physically break into without breaking some things inside of it. And that it would not be cost efficient for an attacker to perform such an attack. Of course, those devices will be more expensive than what we have now. But it's your network. It's your office. So this is up to you, not to me, to make a choice what kind of devices you want to buy.
okay, thank you. So
Thank you.
any last questions from the audience? Yes.
Just make a comment on the biostar, because I think that thing is very interesting if you read it. Also on the comment about storing fingerprint, what biostar did was store the real JPEG image there. Anybody who logged in can go and manipulate everything, and like where, because the whole thing is like you access to the secure area of that building or that premises, so you can manipulate anybody's code and anybody's fingerprint, and can make yourself to access anything, anywhere,
Yeah, you can. Yeah. I think I discussed this. So
yeah.
yes,
So this is the whole breakdown of that thing. Is
once you get hold of such device, you definitely can go and provide yourself with a physical access under different forms. And yeah, I think I discussed that in my talk.
Okay, we run out of time. I'd like to ask Kevin, would you like to choose your favorite question?
I think the first one, I like the first one. The very first question about now
Not
Can you-
from the audience?
from the audience.
Who was that, the first one from the audience? I can't remember now. That was you? Oh, yes, you. Yes, I also
About the
like that
sister
one.
stuff.
Yes.
For the cheating websites.
No.
There you go.
Oh. Well, I liked it too, so you deserve it. I like
Thank you very much.
I like the question about that you asked as well.
Here you go.
Open source. So,
Thank you.
okay, everybody, please give a warm round of applause to Kevin. Well done. So,
Thanks for having me.